Good day, grade 12. Here with me, I have question 8 on calculus from a past exam paper, and I thought we should do this question. There are other sessions that I have posted. Please make sure you find them. This is, by the way, revision number 2 on calculus. Okay, so we are quickly going to go through the questions, and if you need notes, please refer to the first session on calculus. Now 8.1, you need to find the derivative, determine the derivative of f from first principles. Now on revision number 1, I've explained that the first principle is another way of deriving a function, and when they say first principle, there is a principle specifically that you need to use. Okay, you can't use the power rule if they said use your first principle. You use the power rule even if the answer is the same, the procedure is just different, so you get 0. So you need to use first principle. Okay, so the first principle, if you remember from revision number 1, I said this is the formula for first principle. Okay, so first principles, this is the formula which will be given at the back of the question exam paper, and you need not claim it. Okay, you need to just know how to use it, and you need to also know that we call it the first principle. So in the formula, we've got lim as h approaches 0, which we're going to write until the end, where we'll end up substituting h as 0, although h is not 0. Okay, we'll explain that. And then also on the original given equation there, f of x, now we're going to substitute x plus h wherever there is x, and then we subtract the original function f of x, which is 3 minus 2x squared, and then all over h. Okay, now let's start. So I usually do this part of f at x plus h aside on its own. Okay, so my f of x plus h is equals to, from the original equation, 3 minus 2 all times x plus h all squared. Okay, now where there is x, I've actually put x plus h. Then when I expand x plus h all squared, I'm getting x squared plus 2xh plus h squared. Then I distribute the 2, I multiply the 2 everything, all the terms inside the bracket. Then I end up with 3 minus 2x squared minus 4xh minus 2h squared. Okay, that is what I'm going to put here in the first principle formula. So f of x equals to lim as h approaches 0, still written there. And then f of x plus h is 3 minus 2x squared minus 4xh minus 2h squared. Okay, then minus f of x. Remember, f of x was given as 3 minus 2x squared. So we need to multiply with that negative there. The 3 becomes a minus 3. Then the minus 2x squared becomes a plus 2x squared. If this is somewhat not making sense to you, please use your brackets so that you can see how I got these terms here and the signs. Now lim as h approaches 0 of f prime of x is equals to, now we notice that the 3 and the minus 3 cancels. We notice that the minus 2x squared plus the 2x squared cancels, and then we are left with a minus 4xh minus 2h squared. Now what is common between the two terms there in the numerator is h, where h and h cancels. Then I'm left with minus 4x minus 2h. Okay, but also note lim as h approaches 0 is still written. And then now at this point in time, I no longer have h as the denominator, where it would cause an undefined, meaning I can now substitute h as 0. So minus 4x minus 2 times 0, I'll be left with a minus 4x minus 0, which is simply minus 4x. Okay, right there. So the derivative of f from first principles is minus 4x. Remember, you can think of your power rule to confirm whether you have done it correctly. Okay, so when I look at my power rule, I notice that indeed the answer would be a minus 4x. Okay, now well done. Let's go to 8.2. We need to determine, remember, in session number 1 on calculus, I have explained the different notations, 5 of them that we have in calculus, and we can give you any one of them. We can ask you any one of them in the exam. You need to know how they work. Okay, so this was the 5th one in the revision number 1 video, where we've got dx. Then next to dx we put the function that is given. Okay, so remember, when we now derive, that's when we are going to drop the dx. I've explained in the revision number 1 video. Please watch it. Now find or determine 8.2.1 that derivative. Okay, now as we are doing that one, 8.2.1, okay, there's a mistake here. This is supposed to be 8.2.1. Now we are finding dx into x bracket x minus 2 all squared. Remember, also in the first video I said to you, when we have a square binomial like this case here, we first need to expand. Okay, so x minus 2 all squared will be x squared minus 4x plus 4, and then I'm going to multiply all the terms with the x that is outside the brackets. Okay, where I'm ending up with x cubed minus 4x squared plus 4x. Please take note, I haven't derived and I'm still writing my dx. Alright, now I'm deriving, therefore I drop the dx and no longer write it. So the 3 will multiply with the number that is already here in front, which is 1. So 1 times 3 is 3. Then subtract the 1 on the exponent. We are using the power rule. Okay, they didn't tell us to use the first principles. And by the way, we will always have one question on first principle on your paper 1, based on calculus, and then the other problems we use our power rule. Okay, then what's the derivative of minus 4x squared? We drop the 2 to multiply with the minus 4, we get a minus 8. Then subtract the 1 on the exponent, we get a 1. So it will be minus 8x. Then derivative of plus 4x is a positive 4. Okay, so the final answer is dx squared minus, not dx, is 3x squared minus 8x plus 4. Okay, and don't forget, we drop the dx when we are now deriving. Okay, well done. Now let us go to 8.2.2. The question says determine. What are we determining? We are determining dy over dx. Also on revision number 1, I've explained how the notations works. Now dy over dx, I need to make y subject of the formula, then derive x. Okay, so in that way it means I'm happy because y is already the subject of the formula, and then I'm not happy with the square root x in the denominator, so I need to first rewrite that part. Okay, so 8.2.2, let's work it out. Okay, this is point 2. 8.2.2. Alright, so y equals to, this was the given thing, the given equation, y equals to ax to the power 3 over 7 minus 2x all over root x plus 3. Okay, so I first want to fix this, and when I fix it, I notice that, remember, square root of x is x to the power of half. But if I've got x to the power of 1 divided by x to the power of half, then the final answer becomes x to the power of half. Using the laws of exponents, dividing the same base, we subtract the exponents. The exponent at the top minus the exponent at the bottom. Okay, now we end up with this. I haven't derived, I was just fixing this here. Okay, this is one of the rules that you need to master when you are dealing with derivatives. First, rewrite your expressions or your stuff or the terms in the right order so that you can be able to derive them. Okay, now are we ready to derive? Yes. dy over dx, y is the subject, so I'm deriving all of this, and we are told that a is a constant. Okay, so I drop the 3 over 7 to multiply with the constant a, and I'm getting 3 over 7a. Do you see that? And then next up, I have to subtract a 1 on the exponent for base x. Okay, so this is x here. So when I subtract a 1 from 3 over 7, I'm getting minus 4 over 7. Okay, I'm getting minus 4 over 7, and that's what we have here. Alright, so a is a constant, so it is 3 over 7a. Then x to the power, remember now, I subtracted a 1 there, and I ended up with minus 4 over 7. Then minus 2 times the half, it's minus 1. Alright, and then subtract the 1 on the exponent, I'm left with a minus half, because a half minus 1 is minus half. Then what's the derivative of a constant? As explained in the first revision video, that the derivative of any constant is 0. That's why I didn't write anything here, but there is a plus 0 somewhere there, which is not a must for you to write it. Okay, then now your answer stops here. Okay, but if you are asked to write in positive exponents your answer, then the answer will be this final step here. All right, I hope you have enjoyed watching this revision, and please, I've emphasized, check notes on calculus revision number 1. That's where I've explained everything in depth, and then you'll be able to master all of this question 8. Okay, good luck.